Ideas, continuing with exercise 7.3, question number 10. Integral sine power 4x dx. For trigonometric formulas with respect to sine, we have for sine square and sine cube, isn't it? We don't have for sine power 4x. So what we do, we try to write this given question as sine square x the whole square. Anyway, when we multiply the powers, we get back this 4. We just rearrange it here. And we are making use of the formula 2 sine square x. So we know 2 sine square x is 1 minus cos 2x. And we don't have into 2 here. So we can take this into 2 to the right side as by 2. And we replace here. That becomes integral 1 minus cos 2x the whole by 2. The whole square dx. This into 1 by 2. This we have this by 2, yeah, the whole square. We can take outside of the integration as it is a constant. Now we make use of a minus b the whole square formula. That becomes a square plus b square minus 2ab. And we try to split this as 3 integrals. So this becomes, and 1 by 4 belongs to all the 3 terms. So 1 by 4 integral dx plus 1 by 4 integral cos square 2x dx, and minus this 2 we can take outside of the integral, and already we have 1 by 4. This becomes integral cos 2x dx. Now we are considering only this term. So consider integral 1 by 4 integral cos square 2x dx. Since we have power 2, we are making use of the trigonometric formula. As we know, this 2 cos square x formula is 1 plus cos 2x, and we have 2x inside the argument, and into 2 we don't have. Take this into 2 to the right side, and in place of x, write it as 2x. So right side we have 1 plus cos 2 of 2x. So that becomes 1 plus cos 4x the whole by 2. So now the term becomes 1 by 4 into integral 1 plus cos 4x by 2 dx. Now this becomes 2 integrals, yeah, as we have addition in between. So overall, when we substitute in this, we have 1 by 4 integral dx plus we have this 1 by 4 integral cos square 2x as 1 by this 1 by 2 we can take it out. Already by 4 we have. That becomes 1 by 8 integral dx into 1 is dx plus 1 by 8 integral cos 4x dx. And the last term, here this 1, 2 and 4 gets cancelled. We get minus 1 by 2 integral cos 2x dx. When we integrate, this 1 by 4 into integral dx will become x. So x by 4 plus again here the integration of dx is x. So x by 8 and cos 4x will be sine 4x. The coefficient of x is 4 and 8 we have outside. That becomes 32 minus cos 2x is sine 2x, coefficient of x is 2, and already 2 we have out, so that becomes 4 plus c. So we can simplify these two terms, that is taking LCM, that becomes 8. We multiply into 2 here to make it 8. So 2x plus x, 3x by 8 plus sine 4x by 32 minus sine 2x by 4 plus c is the final answer. I hope it is clear. Question number 11. Integral cos power 4 2x dx. It is very similar to the previous question. We make use of the formula 2 cos square x, that is 1 plus cos 2x. We don't have into 2 here. So, and in place of x, we have 2x. So replacing this as cos square 2x equal to 1 plus cos 2 into 2x the whole by 2. That means 1 plus cos 4x by 2. Okay. Rewriting the given question as cos square 2x the whole square. Anyway, 2 into 2 will get the question again. Now replacing in place of cos square 2x as 1 plus cos 2 into 2, 4x, the whole by 2, the whole square. So this becomes integral 1 plus cos 4x by 2, the whole square dx. We can take this 1 by 2 square out as it is a constant, and we can make use of a plus b the whole square, algebraic identity. So 1 by 4 into integral a square, that is 1 into dx is dx. I'm splitting as 3 integrals directly, plus 1 by 4 b square, that is cos square 4x, plus 1 by 4 2ab, that is 2 cos 4x dx. Okay. Again, here we are making use of the formula. 2 cos square x formula is 1 plus cos 2x, taking 2 to the right side. And here in place of x, we have 4x. So cos square, wherever x substitute as 4x, that becomes 1 plus cos 2 into 4x, the whole by 2. Okay. That integral becomes integral 1 by 4 into integral dx plus 1 by 4 into integral. In place of cos square 4x, we write it as here when we multiply, as it is inside the argument, that will become 8x, isn't it? 1 plus cos 8x, the whole by 2 dx. The last term remains as it is. 1 by 4 into this 2 also we can take it out. That becomes 2 by 4 integral cos 4x dx. This will become two terms, isn't it? And integration of dx is x. By 4 we have. This will be, this 2 if we take, it will be 1 by 8 for both the terms. Integration of dx is x. So we have x by 8. Integration of cos is sine. The coefficient of x is 8. And already we have 8 in the denominator. That becomes sine 8x by 8 8 are 64. Here this 2 and 4 gets cancelled, and integration of cos is sine, coefficient of x is 4, 2 already we have outside. That becomes sine 4x by 4 2s are 8 plus c. Previous sum, like previous sum, we can take the LCM for the first two terms as they are similar. 8, so we multiply into 2 here. So 2x plus x, 3x by 8 plus sine 8x by 64 plus sine 4x by 8 plus c is the final answer. Question number 12. Integral sine square x the whole by 1 plus cos x dx. We make use of the trigonometric identity in the numerator part. The reason is, if we replace this as 1 minus cos x formula, the argument will become, I'll just work out and show you. So 2 sine square x is 1 minus cos 2x. But here if you see the argument is x, yeah, then that becomes 1 plus cos x formula is 2 cos square x by 2. The arguments will become different. It is difficult for us to simplify. So we are not using this form. We are making use of trigonometric identity. As we know, cos square x plus sine square x is 1. We are replacing the sine square as taking this cos square to the right side. It will become 1 minus cos square x. The denominator as it is, as we need the argument to be same. If you look at the numerator, it resembles a square minus b square form, isn't it? So we make use of the algebraic identity, a plus b into a minus b, that is 1 plus cos x into 1 minus cos x, the whole by 1 plus cos x as it is into dx. Now, as a whole, this 1 plus cos x gets cancelled. So we have integral 1 minus cos x dx. We can split this into two terms. That will be 1 into dx is dx minus cos x dx. Integration of dx is x minus integration of cos x is sin x. We have the coefficient 1. It is not required to denote that one here. So plus c. This is the final answer. Question number 13. Integral cos 2x minus cos 2 alpha the whole by cos x minus cos alpha dx. If you see, we have the integral, integrating variable is x. This is only alpha in the argument. So we treat this as constant, but it is an addition with addition or subtraction with the other term. So we cannot directly take that out. We'll try to simplify using the trigonometric formulas. So we can make use of cos 2x formula as everything in terms of cos. What we do is, so cos 2x formula is 2 cos square x minus 1. Let's try to use this formula here. So that becomes, in place of cos 2x, it is 2 cos square x minus 1 minus cos to alpha, just replace x as alpha, minus is out, so this plus will be minus, so minus 2 cos square alpha, minus into minus plus 1, the whole by, let the denominator be as it is, cos x minus cos alpha dx. If you see, this minus 1 plus 1 gets cancelled, and in these two terms, 2 is common in there. We can take outside of the integration as common. So cos square x minus cos square alpha the whole by cos x minus cos alpha dx. Again, in the numerator, like previous question, we can make use of the algebraic identity. This can be written as a plus b into a minus b. That is cos x minus cos alpha into cos x plus cos alpha the whole by cos x minus cos alpha into dx. As a whole, this cos x minus cos alpha gets cancelled. When we try to split this as two integrals, as I said earlier, this is a constant. That becomes 2 into integral cos x dx plus this cos alpha, we take it out as we don't have x part in the argument. So it is simply integral dx. Integration of cos x is sin x and integration of dx is x. So 2x cos alpha plus c is the final answer. Question number 14. Integral cos x minus sin x the whole by 1 plus sin 2x dx. We try to use the trigonometric identity and sin 2x formula here. What we do is replacing this one as the trigonometric identity sin square x plus cos square x and sin 2x formula, that is 2 sin x cos x in the denominator. Okay, so now the question becomes integral cos x minus sin x the whole by, in place of 1 it is sin square x plus cos square x, and plus in place of sin 2x it is 2 sin x cos x dx. If you check with the denominator part, it resembles a square plus b square plus 2ab form, isn't it? We can reduce it as a plus bb whole square. Now we can rewrite this as cos x minus sin x the whole by sin x plus cos x the whole square, or you can write cos x plus sin x the whole square. Anyway, both means the same. Now also we cannot directly cancel the terms or making use of the other formulas. It's difficult here. So we try to use the substitution method. Let's try to take the denominator as t. So sin x plus cos x as t, differentiating both sides with respect to x. Sin x becomes cos x becomes minus sin x, differentiation of t becomes dt by dx. Cross multiplying, we get cos x minus sin x into dx will be equal to dt. That means replacing cos x minus sin x into dx as dt, the whole by sin x plus cos x, we have taken it as t power 2 we have. So we can take this to the numerator part as minus. When we integrate, power becomes minus 1 and denominator is minus 1, isn't it? That means minus 1 by t plus c. Then expressing in terms of x as the final answer, that will be minus 1 by sin x plus cos x overall plus c. This is the final answer. Next is question number 15. Integral tan cube 2x secant 2x dx. Here we try to write this tan cube 2x as tan square 2x into tan 2x. And first and foremost, we check with the argument. If this is same, then we continue here. Secant 2x dx as it is. Okay. We try to use the trigonometric identity, that is 1 plus tan square x is secant square x. Okay, expressing this tan square 2x. In place of x, we have 2x here. That is the only difference we have in this question. So replacing tan square 2x as, taking this plus 1 to the right side, it will become minus. So secant square 2x minus 1 into tan 2x secant 2x dx. Now, let's try to take secant 2x as t in this question. Let secant 2x equal to t. When we differentiate secant x, it is secant x tan x into the coefficient of x is 2. Differentiation of t will be dt by dx. Grouping x and dx, dt and constant to one side. Secant 2x tan 2x dx will be equal to dt by 2. That is replacing this as dt by 2 and secant 2x is t power 2 we have. So that can be written as t square minus 1. This 1 by 2 I am taking outside of the integral. This will be dt. So we have two separate terms. That means 1 by 2 integral t square dt minus 1 by 2 into integral 1 into dt is dt. And integration of t square is t cube by 3. And already 1 by 2 we have outside. And integration of dt is t plus c. Now replacing t in terms of x, that will be t, we have taken it as secant 2x. That will become secant cube 2x, the whole by 2 into 3, 6, minus secant 2x by 2 plus c is the final answer. Question number 16. Integral tan power 4x dx. As usual, first and foremost, we try to write this as tan square x into tan square x dx, and we use trigonometric identity for one term of tan square x, that is secant square x minus 1 multiply tan square x inside. That becomes, we split it as two integrals. So integral secant square x tan square x dx minus integral tan square x dx. So here again we make use of the trigonometric identity, and in this first integral we try to use the substitution method. Taking tan x as t and differentiating both sides with respect to x, we get secant square x equal to dt by dx. Cross multiplying, we get secant square x dx as dt. And here we are replacing this as secant square x minus 1. So the next step will become, in place of secant square x dx, we write it as dt. And in place of tan x it is t, we have power 2. So t square dt minus integral. In place of tan square, we can write secant square x minus 1 dx. Now separating this as two integrals. So this we can write it as integral t square dt. This will become minus into plus minus integral secant square x dx minus into minus plus 1 into dx. Integration of t square is t cube by 3 minus integration of secant square x is tan x plus integration of dx is x plus c. Replacing replacing t in terms of x, that will be tan cube x by 3 minus tan x plus c is the final answer. Next, question number 17. Integral sine cube x plus cos cube x the whole by sine square x into cos square x dx. First, we try to split it as two integrals. Okay, so this can be written as sine cube x the whole by sine square x cos square x dx plus integral cos cube x by sine square x into cos square x dx. If we see sine square x gets cancelled, we have one sine x in the numerator. Cos square x gets cancelled, we have one cos x in the numerator. Like how we combine is, we have cos square in the denominator. So one cos x, we combine with this sine x and let one cos x be as it is. Plus, similarly, the same way we do it here. One sine x we combine with cos x into let one sine x be denominator. Okay. Now, using the trigonometric formulas, sine x by cos x is tan x into 1 by cos, we can write it as secant x dx plus cos x by sine x is cot x into 1 by sine, we can write it as cosecant x dx. We know the formula that secant x tan x is secant x plus cot x into cosecant x is minus cot x, minus cosecant x plus c is the final answer. Now, question number 18, integral cos 2x plus 2 sine square x by cos square x dx. First, let's try to simplify this 2 sine square x alone. As we have the formula, 2 sine square x is 1 minus cos 2x. Let's replace that. So the given question can be written as cos 2x plus in place of 2 sine square x outside we have plus, so we don't want to worry about the sign change. It will be as it is. So it is 1 minus cos 2x the whole by cos square x dx. Here plus cos 2x minus cos 2x gets cancelled. This can be written as 1 by cos square x dx. So this will be 1 by cos square x, we can write it as secant square x. So this can be written as integral of secant square x will be tan x plus c. This is the final answer. Then question number 19, integral 1 by sin x cos cube x dx. Okay, let's try to divide the denominator by cos power 4x. Okay. Multiplying and dividing by cos power 4x only in the denominator. So sin x cos cube x the whole by cos power 4x into cos power 4x. Okay. Here if you see cos cube x gets cancelled. So the sin x by cos x can be written as tan x, and this cos power 4x can be 1 by cos power 4x can be written as secant power 4x dx. Next step, rewriting that as secant square x into secant square x. Denominator we have tan x dx. Then for one secant square x term, we use the trigonometric identity. So 1 plus tan square x. Let the other secant square x be as it is, the whole by tan x dx. Now we use the substitution method. Taking tan x as t, differentiating both sides with respect to x. So secant square x equal to dt by dx, cross multiplying and grouping x and dx to one side. So secant square x dx equal to dt. Okay. The given question can be written as, in place of tan square, it is t. So integral 1 plus t square into secant square x dx can be written as dt. The whole by tan x can be written as t. Now splitting this as two integrals. So 1 by t dt plus integral t square by t dt. This will be the direct integration log t, and the next term 1t gets cancelled in here. So integration of t is t square by 2 plus c. Now replacing t as whatever we have taken, tan x. So log of tan x plus tan square x by 2 plus c is the final answer. Question number 20, integral cos 2x the whole by cos x plus sin x the whole square dx. So here we try to use the cos 2x formula in the numerator part alone, that cos 2x is, as we have cos and sin terms in the given question, so we replace this as cos square x minus sin square x. So the numerator of the given question becomes cos square x minus sin square x the whole by, let the denominator be as it is. Okay. So now the numerator is in the form a square minus b square form, isn't it? So we can write that as a plus b into a minus b. That is cos x minus sin x into cos x plus sin x the whole by cos x plus sin x the whole square. Okay. If you check with the terms, we can cancel cos x plus sin x as a whole. So we get integral of cos x minus sin x the whole by cos x plus sin x dx. Now we try to make use of the substitution method to solve, taking denominator part as t. So cos x plus sin x equal to t, differentiating both sides with respect to x. Cos x becomes minus sin x becomes cos x, t becomes dt by dx. Here we have cos x minus sin x. Yeah? We try to rearrange the term. Cos x, writing the positive term, then the negative term, the whole into cross multiplying dx to the other side, that will become dt. So the given question, so cos x minus sin x into dx can be written as dt, the whole by cos x plus sin x, we have taken it as t. The integration of 1 by t dt is log t. Replacing t in terms of x, whatever we have taken, that can be written as log of cos x plus sin x plus c is the final answer. Question number 21, integral sine inverse of cos x dx. Okay, if we have to try to simplify this inverse, yeah. So let's try to cancel that inverse by using some trigonometric formula. Inside the argument, we have cos x. So we make use of the complementary angle that we have studied in class 10 and 11. So cos x can be written as its complementary angle, sine of 90 minus theta. Here we have x in the argument. So the given question can be written as integral sine inverse of, in place of cos x, we can write it as sine of pi by 2 minus x dx. And from the inverse trigonometric chapter, we know that the sine inverse of sine x can be written as x, yeah, because we have inverse and trigonometric. So that gets cancelled. So this step can be written as integral. The argument alone we have, that is pi by 2 minus x dx. Now separating this as two integrals. If you check here, we don't have any x terms. That means it is a constant. So we can take outside of the integral and we can write it as pi by 2 into integral dx minus integral x dx. So integral dx is x. So we can write it as pi x by 2 minus integral x is x square by 2 plus c is the final answer. Either you can group this terms as we have denominator same, pi x minus x square plus c, if you write like this also, nothing wrong. Okay. Question number 22 is like a bit lengthy one, and it's important question in this exercise. We have the question integral 1 by cos x minus a into cos x minus b dx. Directly, if we try to use 2 cos A cos B formula, it is in the denominator part, it is difficult for us to integrate by taking the reciprocal function. So first step, what we try to do here is we multiply and divide by sine of A minus B first of all. Okay, so this way inside the argument, we don't have x terms. So it is a constant. So division, we don't need that. The division part, I'm taking outside of the integral. But numerator part, we need. We'll do some rearrangements again in the next step. So I'm writing inside the argument. That is inside the integral part. So sine of a minus b by cos of x minus a into cos of x minus b. Okay. Now inside this argument, we add and subtract x so that we can try to make in this form. So 1 by sine of a minus b into sine of a minus b plus x minus x. As I told, adding and subtracting x inside the argument, and the other terms as it is, cos of x minus a into cos of x minus b dx. Now, grouping the terms, in denominator we have x minus a, x minus b. So we can group this plus x and minus b, minus x and a. What we can do is, that is 1 by sine of a minus b into integral sine of plus x, I'm writing first, minus b next. And I have plus x in both the arguments. Yeah. So I'm taking minus 1 as common. So this minus x becomes plus a becomes minus. So we get the arguments as whatever we have in the denominator. So denominator as it is, cos of x minus a into cos of x minus b dx. Now the numerator resembles sine of a minus b. So sine of a minus b formula is sine a cos b minus cos a sine b. Yeah. So we try to replace. Here a is x minus b. We have to take x minus b as a, and we have to take x minus a as b. Don't get confused. So this last step, we can write it as 1 by sine of a minus b outside as it is. Numerator part, sine a cos b. That is sine of x minus b into cos of x minus a. As it is a minus b formula, in between minus, cos of x minus b into sine of x minus a. the whole by cos of x minus a into cos of x minus b dx. As we have subtraction in between, we can split this as two integrals. Let this 1 by sine of a minus b remains common outside. This can be written as sine of x minus b into cos of x minus a, the whole by cos of x minus a into cos of x minus b dx, in between minus cos of x minus b into sine of x minus a, the whole by cos of x minus a into cos of x minus b dx. Okay, checking with the cancellation of terms. If only the arguments are same, we can cancel. So only we can cancel cos of x minus a, cos of x minus a in the first term. In the second term, cos of x minus b, cos of x minus b. So 1 by sine of a minus b remains as common outside. So here we have the argument same, yeah. So sine by cos, we can take it as tan of x minus b dx, in between minus. Again here sine by cos, arguments are same. This can be written as tan of x minus a dx. Integration of tan, we know log secant, isn't it? So this can be written as 1 by sine of a minus b. Integration of tan is log secant. In place of x, we have x minus b. We don't have any number as coefficient, is plus 1. So we can remain as it is. For the next term, it is log secant of x minus a plus c. We know the logarithmic property. Yeah? Log m minus log n can be written as log of m by n. So 1 by sine of a minus b into log of secant of x minus b by secant of x minus a, the whole plus c is the final answer. If you have any doubt in this particular question or overall, please post it in the comment section. Feel free to ask your doubts. Now, question number 23. Integral sine square x minus cos square x, the whole by sine square x into cos square x dx. We try to separate this as two integrals. This can be written as sine square x by sine square x cos square x dx minus integral cos square x by sine square x cos square x dx. If you check with the cancellation of the terms, sine square x gets cancelled, cos square x gets cancelled. So we have 1 by cos square x that can be written as secant square x dx minus we have the remaining 1 by sine square x that can be written as cosecant square x. And we know the formula for integration of secant square x is tan x. For cosecant it is minus cot x. So this can be written as minus of minus becomes plus. So the correct option is A, that is tan x plus cot x plus C. Question number 24, integral e power x into 1 plus x, the whole by cos square, inside the argument we have e power x into x dx. We try to take the argument whatever we have as t. So e power x into x equal to t. It is differentiation. We have product of two terms. So we use uv method, that is uv dash plus bu dash. Taking e power x, differentiating x, we have 1 plus x into differentiating e power x, we have e power x. T will be dt by dx. Taking e power x as common, it is 1 plus x into dx equal to dt. So this given question can be written as, we have e power x into 1 plus x dx as a whole in the numerator, isn't it? So that can be written as dt. Denominator cos square of e power x into x can be written as t. So that can be written as secant square t dt. We know integration of secant square is tan plus c, replacing t in terms of x. So tan of x into e power x plus c is the final answer. And the correct option is option B, tan x into e power x, tan of x into e power x. Okay, I hope it is clear. In the next video, we continue with exercise 7.4. Thank you.